You're running a newspaper stand, deciding how many papers to stock each morning. Some days you sell out early, while other days you're left with a stack you can't sell. How do you decide the right number of papers when demand changes day to day? And how do you balance running out versus having too many left over? There's a model for that. Welcome to Model Monday, a series where we break down scenarios in different industries, organizations, and departments, and explain how you can build a simulation of them in Process Playground. Let's model it. In this episode, we're going to build a model of the newspaper dilemma, also known as the newsboy problem. The goal is to find the sweet spot for how many papers to order by comparing demand, sales, leftovers, and financial outcomes. We'll start by creating our item types. First, create an item called newspaper. This is the inventory we're trying to sell during the day. Next, create an item called customer. This represents demand that arrives over time. Then create an item called sale. This will represent a completed sale. It will be a combination of a newspaper item and a customer item. And when we're building the model, we'll use a kit block to bring those together. Next, we'll create an item called return, which will be used when returning our paper. And our last item is a returned paper. We'll use these at the end of the day to account for any newspapers we didn't sell. A returned paper is made up of a newspaper and a return. Now we can start building the flow. First, drag out a demand block. This block is going to represent our customers coming to buy newspapers. So we're going to add the customer item here. For the demand pattern, we're going to set it to an exponential distribution with a mean of 3 minutes. This gives us an average of about 20 customers per hour, but with some randomness in when they arrive. Next, let's add a Q block and we'll name it unsatisfied demand. This is where customers will wait if newspapers aren't available. So if a customer shows up and there's inventory on hand, we can fulfill that demand, and if not, they'll remain here waiting. Now we're going to create our supply of newspapers. Add another Q block and name it initial buy. This will represent the newspapers we start the day with. We're going to turn off allow all items and add the newspaper item to this queue and set initial on hand to 300. So, at the beginning of the simulation, we already have 300 newspapers available to sell. Now we're ready for one of the key blocks in this model, the kit block. Drag out the kit block, and then we're going to connect the initial buy block, which contains our newspapers, and our unsatisfied demand queue, which has our customers, to this block. The kit is going to combine different items together to create new items, as we defined in our item types window. When we open up our parameters by double-clicking on the block, we'll first add the sale item. This is how we will model a completed transaction, by combining a customer and a newspaper. We'll also add our returned paper item, which is the combination of a return and a newspaper. Let's handle that next. We'll add a second demand block and name it return at end of day. This block will create the return item, so we'll remove the newspaper item and add return. We want those returns to happen right at the end of the day, so set this demand to start at 719, which is 1 minute before the end of our 720-minute day. The goal here is simply to make sure that any unsold newspapers still sitting in inventory get consumed at the end of the day. We're going to set this as a constant of 0.01 minutes. Because this represents the time between arrivals, setting this number low means we'll get a large number of items very quickly. Now we'll connect this demand block to the kit block. This one kit block is doing 2 jobs for us. During the day, it combines customers and newspapers into sales. And at the very end of the day, it combines return requests and leftover newspapers into returned papers. That's a really useful example of how a kit block can work with different item combinations inside the same model. Now let's get the items to exit. First, we're going to add a Q block and rename it sold. Then we'll turn off allow all items and add the sale item. This means only sale items will be able to go down this path. Then we'll connect that up here. Then we'll add an exit block at the end. Next, we'll deal with the returns the same way. We'll create a new queue and we'll rename it return. We'll turn off allow all items, then add the returned paper item. Then we'll connect it all up, and then we'll add our exit block. At this point, the main flow is built. We have customer demand arriving, newspapers available from the initial buy, completed sales moving through one exit, and leftover papers leaving as returns at the end of the day. Now, let's add some financial tracking, and this is where accumulator blocks come in. First, add an accumulator block and name it cost. This will track the cost associated with each outcome. In this dropdown, we'll add the block called sold and set the accumulated value to a constant of 0.2. That means it costs us 20 cents when we buy a newspaper that eventually gets sold. We'll also add the return block, and we'll set the accumulated value to 0.25. Not only do we have the initial 20 cents that we purchased the paper at, there's an additional 5-cent cost associated with returning it. Now, we'll copy and paste that block to create a new accumulator block, and we'll rename it revenue. In the sold block, we'll set the value to accumulate to 1. This means we earn $1 in revenue for each paper sold. For a returned paper, we'll set the accumulated value to 0.1. This means we recovered 10 cents for each returned paper. So now we have one accumulator tracking cost and another tracking revenue, and both of those values are going to be attached directly to the items that move through the model. Now we're ready to run the simulation. Set the model to run for 720 minutes and use one run. Then start the simulation. As it runs, you'll be able to watch the number of available newspapers decrease throughout the day as customers arrive and sales are made. Then, right at the end of the day, any leftover newspapers get converted to returned papers. In the run shown here, we sold 270 newspapers and returned 30. Your exact results may look a little different, and that's completely normal. This simulation has randomness built in, so even with the same settings, the exact outcome can vary from run to run. That's one of the strengths of simulation. It lets you explore a range of likely outcomes instead of assuming demand always behaves the same way. Once the run is complete, we can start looking at the results. First, double-click on the sales exit block and go to results. One of the easiest things to look at here is count, because it tells us how many sales were completed. You can apply that to all exit blocks so you can quickly compare sold papers versus returned papers. Next, if you want to inspect the financial side, open the accumulator block and choose View Item Report. In this report, you'll see all of the items that were created during the simulation. You'll also notice there are a lot of NA values in the table. That's okay. We don't really care about analyzing the raw newspaper, customer, or return items here, so we're going to use the checkboxes to hide those items from our list. The most important ones here are the sale items and the returned paper items, because those are the items carrying the cost and revenue values. So, here at the top are our sales, and down at the bottom are our returned papers. From here, you have a couple of options. You can export the item report to a CSV and analyze it in Excel, or you can export it directly to Engine Room for further analysis. Either way, this model gives you a simple way to compare how changes in stocking decisions affect both operational and financial results. So in a nutshell, that's the newspaper dilemma model, but the real value is in what you can experiment with. By modeling uncertain demand and limited inventory, you can see how different stocking decisions affect both lost sales and leftover inventory. And it's not just newspapers. The same pattern shows up in retail products, fresh food at a grocery store, vaccines in a clinic, or any situation where you have to decide how much to stock before demand is known. From here, you can start to ask real design questions. How much should I stock to balance risk and reward? What happens if demand becomes more unpredictable? And how do costs of leftovers versus stockouts change the decision? Those are the kinds of trade-offs this model is built to explore.
That's the model. Now go experiment. Happy modeling!